delayed matching to sample, DMTS, is the procedure commonly used to study non-humans' short-term memory. In this procedure, each trial begins with the presentation of a sample stimulus. The subject must touch this stimulus. The sample is removed for a period of time corresponding to the delay that longs at least 0 seconds. At the end of the delay, 2 or more comparison stimuli are presented. A response to the comparison stimulus that matches the sample S+ is reinforced and initiates the intertrial interval. Responses to the comparison stimulus that doesn't match the sample is only followed by the ITI. Studies indicate that the contamination by methylmercury can produce behavioral and cognitive deficits, including short-term memory, especially in children intoxicated from the intrauterine period. This research has been conducted for 3 years, aiming to characterize the non-intoxicated organism's performance in the DMTS, particularly in capuchin monkeys as subjects. Posteriorly, a research will be conducted in parallel with this project in a translational model, assessing the intoxicated and non-intoxicated children's performance on the same task, seeking possible changes that intoxication can generate. Research about DMTS with non-human subjects indicate a decrement in the accuracy, as the delay between the disappearance of the sample and the appearance of comparisons is increased. However, increases in the intertrial interval can produce a recovery of the accuracy. That is, the higher ratio of ITI to the delay, the better the performance. Over the years of development of this research, we studied the effects of gradual increases in delay 0.5 second, and gradual increase in the intertrial interval in 1 second. The manipulation of the ITI occurred when the delay's manipulation produced a decrement in the performance to below 90% of correct choices. 3 experienced capuchin monkeys served as subjects in the DMTS task. Rawl, arbitrary DMTS, Dracula, and Tico, identity DMTS. Initially, all subjects were inserted in the procedure in which the main objective was to verify the effects of the gradual manipulation of delay in ITI. Also, to provide conditions that could further the acquisition of high accuracy at the DMTS performance, when longer delays are trained. At first, when the subjects reached the criterion of 90% correct in a session with delay 1 second, and ITI 6 seconds delays, manipulations were initiated. The manipulations consisted of increments of 0.5 second on delay. When the subject's performance was deteriorated, that is, the subject performance 80 to 87% correct for 3 consecutive sessions, or less than 79% correct in 1 session, the ITI was increased in 1.0 second. Currently, the task for each subject presents different peculiarities and only one subject keeps on task with the characteristics mentioned. Tico. For this subject, a session consists of 9 trials that contain 9 identity relations. Each trial presented 3 comparison stimuli. Nine different delay values were randomized in 18 trials, short, medium and long delays. Tico currently is in training with maximum delay 64 seconds and ITI 23 seconds. The remaining subjects, Dracula and Raoul, were submitted to tests of combinations of delays and ITI. In the phase of gradual manipulations, Dracula was trained to the maximum delay 34 seconds and the ITI 38 seconds in sessions composed by 18 trials with 9 identity relations. Terral, gradual manipulations of ITI from 15 to 22 seconds were not sufficient to promote acquisition of accuracy with maximum delay 11.5 seconds in sessions with 20 trials and 10 arbitrary relations. In the combinations tests, each session consisted of 2 values of delay combined with 1 value of ITI. The tests were developed aiming to map which combinations could improve the task's performance, especially at trials with long delays. Were used with Dracula, 4 values of delay, 1, 7, 16 and 34 seconds, and 4 values of ITI, 6, 10, 20 and 38 seconds, totaling 24 sessions. For example, a session could be composed by the delays 1 and 34 seconds and the ITI 20 seconds. Each session was presented 2 times. Dracula's data did not show a performance indicating the best combination of delay and ITI that could improve the accuracy in the longer delay. 2 groups of different delay values were used with Raoul. The first group tested delays 1, 3, 6 and 12 seconds. The second group was composed of the delays 1, 4, 7 and 14 seconds. For both groups the values of ITI tested were the same, 6, 12 and 22 seconds. High accuracy in the longest delay of the first group of combinations, 12 seconds, was performed when it was combined with the less delay, 1 second, and the less ITI, 6 seconds. This result was not replicated with the second combinations group. The data did not show a performance indicating the best combination of delay and ITI that could improve the accuracy in the longer delay. In general, this research supports results obtained in previous studies, that is, the performance in DMTS suffers a decrement when the delay between the sample and comparisons is increased. Also, the performance is recovered when the ITI is increased, but it doesn't mean that the ITI must be longer than the delay. TICO performed high accuracy even when the ITI was lower than the delay in the manipulations phase, and the same occurred to the other subjects in the phase of combinations test. These data suggest that the simple difference in length of the delay and the ITI can produce an improvement in the performance. TICO continues in the same task, training larger delays in the phase of delay and ITI's manipulation. Dracula is in the third replication of the combinations tests, and a baseline of identity relations is being established with RAL, so a parallel between arbitrary and identity DMTS will be done. Moreover, the DMTS task is being adapted to be applied in intoxicated and non-intoxicated children.